This is one of a series of videos to explain the setup and operation of the WW9JD Arduino µMatic² memory keyer. I am Rick Dubbs, WW9JD. This is a brief overview of the software and hardware features of the WW9JD Arduino µMatic² memory keyer. It is both an update of and homage to the original Heathkit µMatic memory keyer that I built in the early 80s. The core functionality of both keyers is nearly the same, and as you can see from this point down, the keyboards are nearly identical. You can further see a list of features printed in the notes below this video. The root purpose of this, as well as any other electronic keyer, is to generate the dits and das that are used in Morse code communication. While old-style up and down railroad type telegraph keys are still in use, that sort of a motion can be fatiguing if you're communicating for a long time. It was found that a side-to-side motion was more comfortable over a long period of time, and the first sidewinder keys use a pendulum system to automatically generate dits with the left hand paddle and then das with a right hand movement that you held as long as you needed to. With the advent of electronics, keyers were developed that made use of two contacts to self-generate dits and das in place of making use of a pendulum. By way of various settings, this keyer allows the generation of dits with the left-hand paddle, das with the right-hand paddle. That can be reversed so that dits are with the right and das are with the left. And it can simulate an old-style sidewinder paddle by self-generating dits with the left-hand paddle and allowing you to complete das of any length with the right-hand paddle. While I have the keyer set at 10 words per minute right now, this can be set anywhere from 1 to 99 words per minute. At 1 word per minute, a dit takes a rather long time to complete. At 99 words per minute, it's awfully fast. The keyer will allow itself to just be turned on so that you can tune your radio. The practice mode on this keyer merely disconnects the keyer from the radio so that you can practice without keying the radio. Repeat allows you to repeat a message up to 99 times. The load and send keys allow messages to be saved to and retrieved from the memory. Mute will mute the side tone itself, so you're just hearing the tone that your transmitter produces. To load a memory, you tap a number key and then load. That moves you over to a screen that has a QWERTY keyboard so that you can enter the message you want. In this case, how about hello? And then end file. And that was file number 4 that I saved that as. So let me play back. Go back to our main screen. Let me play back file number 4. The software allows for the use of some command characters entered over here on the QWERTY keyboard page. This is an index that's used in contesting so that you can serialize your contacts. This is a pause character. These two characters are used together to send a couple or 3 characters without any space in between. There are some predefined words here, sequences of letters that you might want to send. There are also screens for setup. This sets up the display itself. This one are parameters that you can change for the keyer. There's also the ability to have some reference screens, like a call area map or Q codes that amateur radio operators use. All of the graphics for the keyer are programmed into the Nextion display itself and programmed with the Nextion Integrated Development Editor, or IDE. The software for the program is programmed into an Arduino Mega 2560 Pro embedded microprocessor. The electronics are mounted on a custom designed printed circuit board. Here is the printed circuit board without any components on it. This is the area for the Arduino microprocessor. This area here is for installing a card that will allow the insertion and use of a micro SD card. Because there are many micro SD cards available on the market, this field was made rather than a single installation set of holes so that different cards can be used. In a similar fashion, this area up here is for where you might put an optional power switch, and once again you have a field of holes here so that different power switches might be used. Down here is a connection where you can connect a iambic paddle that is compatible with an Elecraft KX3 transceiver and have a paddle hooked up directly to the keyer. Here is the back side of the keyer with the components installed. The Mega 2560 Arduino microprocessor. This is one variant of the micro SD card that has been used with the keyer, and this is one way to install the switch to be used with the keyer. The rest of the components are relatively standard. 3-conductor 1/8" stereo jacks, a couple of opto isolators to go in between the Arduino microprocessor and the transmitter, a piezo speaker for side tone. Those are the connectors there for the key. When the key is used, it does turn an LED on the board. The manufacturer of your board would determine whether or not that LED is blue or red. Those are the only two variants that I have seen. With the paddles installed, you have a fairly compact package for portable operating, though it is lightweight, so you may have to hold it in place. The traditional farewell between ham radio operators is 73, which means best regards. Also,